Star, but we don't want to stop for North Stars. We can always work towards that. But let's
so let me tell just a minute. So Marian, I'm Marian manager, so actually I know what he's doing, and
okay.
So it's not like So what we did up till now, we have a working model on top of V1 model, like BMV2, V1 model, and the reason we started with a V1 model, not because it's a good idea or it is a good model representing any one hardware. It's more like this is what exists and this is what's currently working. And this is what currently people are using in order to make a compilable and a model in which you can simulate. We can simulate. And this was the main purpose here, to try to establish some kind of a reference model that we can all use in order to test our implementation based upon, and to have something that is accurate and we can read and understand what is expected in terms of implementation.
I think the key word that you said, though, is you can simulate it.
Right.
But that's very important right now, that we have something that we can simulate.
Exactly.
Where simulated where? Simulated where? Because no simulator of public domain simulate that code.
Yeah, and it's also not BMV2, because there are
exactly.
No, just a minute. It is based on BMV2 and it is working. So
working where?
Working where?
On the BMV2. It is
no,
modified
BMV2.
No, it is. What do you mean?
Well, I mean, modified, yes. If it is an NVIDIA tool, fine. But it's not a public domain tool.
Just a minute. This is something we can share with the community. It's not a problem. We have a working model in which we can share the code, and we will share the code. It's not something that is private to NVIDIA. It is not something which is NVIDIA target architecture. It's the V1 model modified to add the needed capability for Dash.
Okay. So it's not the BMV2, and it has functionalities that are non-existing and non-included in BMV2 and in the PSA in the PSA specification.
No, it's not around the PSA. It's not around the PSA specification, and it's not around the PNA specification. It's around that specification. This is what we would like to do. And the question is, what we are looking for? We are looking for a Dash simulator and the right tool to simulate Dash, and on the other end, to be quite expressive, like to describe Dash pipeline. This is what we are looking for. So as a community, right? So currently, the best available model that we found was V1 model as a target architecture and BMV2 as a baseline, and we modified BMV2 in order for that to compile and run our P4 Dash code. And we are going to extend it furthermore in order to support stateful operation, like our connection tracking table, and so on.
Wait, you must have extended it already, because in order to execute the code that we currently have in the repository, it has to be extended, because connection tracking is there with graphs, with state graphs that are not BMV2.
So Mario, currently what we have is a code that can run without the connection tracking tables, without the stateful ones. We are going to, actually we have an extension that already works with the stateful operation that look like connection, so that can implement connection tracking. It is under work. It's currently not working, but this is the plan.
But then why don't we go directly to PNA, since PNA is the future? Then why do we go to something proprietary that doesn't exist?
Yeah, they are exactly in the same situation. They are both North Stars, to use what we said before. They both are ideas that don't exist, but one is standard, the other one is not.
I guess the question, Maddie, would be, is there a plan for NVIDIA to publicize their changes to BMV2 within a month or two?
Yeah, of course. Again, nothing. It's not around us. It's not around NVIDIA writing closed source. We will publish all the code that we added to BMV2 for the Dash project.
But do you have
nothing.
a time? Do you have a time frame in mind?
No, we can. I do not have a time frame for in mind. We can share it next week or the week after, because I believe that next week no one will be there.
So basically now, so that it's not months from now. You're talking about a week or two.
Yeah, Gerald, but if we go in the wrong direction, then we are on a path in the wrong direction. We are on a divergent path forever. While we now is the moment to go all aligned and try to not diverge.
Again, let me again. We have the same. We have a shared target. Our target is to have a simulator for the Dash. So if there is an available one, just a minute. Let me finish. If there is a one that available that we can run in a time frame of a month, fully functional P&A model simulator, and P&A, assuming P&A is defined in a way that actually it can implement Dash, which is, by the way, not the current situation, then fine. But I don't believe this is the case. So if we are talking about a half a year from now, so I believe it's not realistic, because we are looking for a simulator that we can use tomorrow.
That's right. Because guys, we have hardware today that can be tested. We need a simulator today so that we can start making that testing easier. We can move over time to maybe even a more standard simulator, but right now we already have hardware that we can be simulating against. So to help that, we want to have software simulators so that we can build those test cases quickly. We don't have to be waiting at all for that.
Yeah, there's another nuance.
We have something like right now within weeks that we can have to help the testers build test cases in scenarios, and they can build that as the hardware gets ready. But we have hardware. Some of the hardware is already got Dash code. We need a simulator now, so we need to get ahead of it, not behind it. We don't want to actually have simulators arriving, 3 months from now after Dash hardware is already available. We want it before.
Thing you said in the previous meeting, we want to make sure that the simulator has the same functional API interface as the hardware, which was decreed as being the SI interface and not P4 runtime or something like that.
Correct.
So
it has to be the SI, and this model that they have actually does generate the SI.
No, does it? It may generate APIs. Does it have a SI lib/SI interface bound to the model? That's a different thing. In other words, can you program it with SI?
Maddie can answer that.
Okay, so I'm going to address that. So what we have currently is the two separating. We have, let's put the connection tracking aside for a moment, and I will get back to connection tracking in a minute. What we have is a working simulator based on BMV2 and the current P4 code, which is part of the Dash. And currently the simulator is, we are using P4 runtime in order to configure the simulator rules, not SI. In addition to that, we have an compiler or front-end compiler that can translate the P4 code into auto-generated SI API. Now, this is the current status. Now, our plan is first to do the following things. First is, and those I'm saying them in the priority that we would like to address them, and actually it's more call for action, assuming we agree on the plan.
Yeah.
So the first is to create a SI to P4 runtime wrapper. It's not a big deal. We estimate that as weeks of work, like 2 or 3 weeks of work, in order to create this wrapper between SI and P4. And after that, we can actually configure the model in Dash SI, both overlay and underlay. Later on, like the next stage is while introducing SI stateful interfaces, which is currently we have a working group trying to standardize SI stateful API in order to be able to express table-like connection tracking.
Matty, is that PNA, the workgroup that you just mentioned?
No, it's not a PNA.
Okay.
This is related to Psi, completely to Psi.
Okay.
So, Matty, I have a couple of questions on what you just mentioned. Did you say that those Psi APIs for overlay are generated? They're auto-generated?
Yeah. Yes, they are.
So they are auto-generated from the P4, P4 models that are written right now, right?
Right.
Okay. So, and then you also mentioned that there is going to be a mapping between Psi to P4 runtime, right? And then you were mentioning that you for both underlay and overlay. However, currently underlay APIs are not auto-generated. They are for basically, and there is no P4 model for those underlay APIs. So what are you saying in terms of from the P4 runtime for both underlay and overlay?
Sorry, I didn't catch the like the last minute. So can you repeat, please?
So, yeah. Sorry, Mary. So what I was saying is that you said that there will be a P4 runtime mapping from Psi for both overlay and underlay APIs. However, today the underlay APIs, there is no P4 model for it, right? They are defined, outside of it. So how do you plan to do this, right?
So we are going to create P4 model for the underlay.
Okay, so that's another item that yet to be done, right?
Yeah. So you are completely right, and the reason I didn't raise it because it's not, there is no gap there.
Sure. I know. I just want to capture it to make sure that there is a to-do thing, that were to happen if we need to do an entire simulation. This is yet another item that needs to be taken care of, right?
To me, it's more than that, because independently of underlay and overlay, even let's talk about overlay. Overlay will be partly controlled by existing API and partly controlled by Dash API. So the simulator must be able to take both.
Actually, overlay is going to be completely controlled by Dash API.
No, because if it has a routing table, the routing table is a side table.
Actually, it is all around the Dash. So we are not going to use, again, specifically on Dash. So it's not related to the fact that we can express the legacy Sonic routing table in P4 and use that as well. But orthogonal to that, the current overlay API in Dash are pure Dash API. We are not using legacy Psi in order to configure the overlay.
Yeah, not for the overlay, for the underlay, you were saying.
No. So for the underlay,
we were talking about the overlay. We were talking, yeah.
For the overlay, there is no plan to use existing Psi API. It's all about the new Dash API.
Yeah.
And Microsoft is okay with that.
Yeah.
Who do we have here? Do we have Guon or Prince or anybody on the Microsoft side?
Let me check while we talk.
So go on here. Again, this is something was agreed with Gon and Prince.
Okay, well.
Yeah, this all makes sense. They're orthogonal in a way, or parallel independent. Matty, I'm really impressed that you guys are going to have all this working in the relatively near future, and it sounds like a really good, a really good tool to have. I wanted to just pause for a minute and ask Reshma how things will go with the P4DK implementation, which will also ultimately have a Psi interface, and it's be closer to line rate type model. And does the community want to eventually invest its resources in that as the preferred simulation vehicle, or will there be room for two?
Just a quick comment. Thanks, Chris. Was that definitely, as I mentioned last week as well, that currently we need a simulator, and Matty and Marianne, and I think Mario will be adding more on top of this. That's what I learned last week. It is really important. I agree with that. with the PNA P4, if you use P4 DPDK performance is definitely better. One thing I want to mention is that we have an interface, from the P4RT, which can consume the P4 information today in Sonic. And quick update about the underlying layer in the Sonic SyncD, right? For the SI adapter portion, when it interfaces with the programming layer for the P4DPDK, there will be no additional gRPC, there will be no additional RPC there. It will be a direct call into the programming library. So there is that part there as well. Yeah.
Can I share my diagram right now?
Yeah, let me stop presenting.
Okay, thanks. So I know we're going all over the place, but this is sort of a knowledge leveling opportunity, right? And it's exciting to hear what Maddie had to say. I also I updated this diagram, which some of you may have seen in previous meetings. It's kind of a lot to digest, but different from the last version you saw. Sorry, something happened with my screen. I've got the P4 DPDK implementation over here shown as just another example of a device under test, or what we call DUT. So as Reshma was saying, the normal design for P4 DPDK, it has an intermediate layer, which is really a C++ interface, table-driven interface, or TDI. That's on p4.org, p4lang. It's really kind of barefoot runtime put out into the public community. And so this is a performant, directly compiled backend. On top of that, they have a P4 runtime server, which theoretically we could use, but in the context of dash testing, it's probably not particularly.
Yeah, and in context of Sonic, it's not required.
Right. But it's part of the architecture, and I want people to understand this. What we would do for Dash is Intel would have a libsci wrapper of some sort or adapter that is linked to this table-driven interface. And then there could be a sci-thrift server on top of that for testing, just like there's a sci-thrift server on top of whatever vendor's libsci. So this is sort of the architecture, and I embedded this with both Andy Fingerhut and Reshma in the background last week, just to make sure it wasn't off base. So this shows that this would be pretty performant. There's no P4 runtime intermediate server from the standpoint of simulation. But if there were test cases developed, for example, by NVIDIA that had P4 runtime, they could be applied to this interface too. So there's some commonality. But we could say that there's this simulator and a BMV2 simulator right next to it. And the only difference should be performance. And the community can decide, do we want both? Do we want to start with BMV2 as it's near at hand and then progress to DPDK? And then put BMV2 on the shelf and say that was really helpful, but we don't need it anymore? Those are the kind of questions I think that will be addressed by this group.
Yep.
I'm sorry, I did not understand when this is going to be available.
That's for Reshma to answer.
Yeah, with Reshma.
Yeah, it is not fully ready as yet, and the P4 DPDK functionality just basic layer 3 has been tested so far, and we're integrating that with Sonic. As I mentioned, some bit of testing has happened there, but a lot more features need to be added, and then that will take some time.
I believe that, and again, we really, as NVIDIA, we are not in love with what we did. We just want a functional simulator. We're really not in love.
Mm-hmm.
Believe me, we love PNA, and we like to have a DPDK backend in order to have and kind of a software efficient an efficient software switch which is currently lacking. We are lacking. So whether it is critical for the simulator, I'm not sure, but if there is a better backend, let's use it. The only reason we use BMV2 because it is there. And we believe that in a matter of weeks, we can make it work. Like we can come up with a fully functional simulator for Dash like 90% is already functional. So we can add 10% and it will be fully functional. The question is how far is the DPDK backend from being fully functional? And I believe
my guess is if you're 90% of the way there, I suspect you're going to win that race, and I don't have any problem with that personally. I did want to just double check with the deciders or the Dash group. I imagine a reference model that's like the code is available to all of us to run and download, and it's either all open source or at least under some open license. Is that a requirement or just a very nice to have, or at least for the reference model, it seems preferable to have open source for most or all of it, I would guess.
It will be handy. We don't have any plan to like all the code that we are writing, adding, modifying for the BMV2. It will be open on the Dash repository.
Okay, great. And if that's the requirement, then that meets it. Great.
Hey, Chris, I have a quick question on this, just for my understanding.
Yeah.
I believe this the stack that you have shown, P4 DPDK, TDI, and P4 RT, it's like reversed, right? I mean, in other words, you're going up as in terms of from the flow perspective.
Yes.
That correct?
Hanif is right. But the arrow here, Hanif, as Chris has drawn it, it comes in the bottom, and I guess there's another arrow. If it shows, an internal arrow from green, blue, and red boxes, that'll be good.
Yeah, exactly. So I think the way it should be that from LibSci you go to P4RT, and from P4RT you go to TDI, and then eventually you go to the P4 DPDK and out.
No, actually, let me correct that. LibSci is compiled runtime library, or it'll be a wrapper compiled to this TDI, and P4 runtime is not even used. Just want to use Sci.
Okay, so I think so. Then what was if you for clarity's sake, then we can probably remove P4 property. But wasn't there a discussion about this wrapper of LibSci or the Sci APIs calling eventually the P4RT, and then you basically
that was the BMV2 version, which I haven't.
Oh, that's a BMV.
Even in Sonic, I think there is no need for additional P4RT between Sonic and the programming layers like TDI. That's there. If we were to use without Sonic, P4RT with other means of testing, then P4RT can exist there. That is just above the TDI programming layer.
Yeah, based on this discussion and Maddie's description of progress, which is really exciting, I'm going to redraw this. So this is just a simpler box that says P4 software model with interface, Sci interface, and optional P4 runtime interface. And then I'll have another page that expands to show the P4 DPDK stack a little bit better and the BMV2 stack. So this diagram becomes simpler. So because no matter how hard I try, whenever I draw a diagram, someone says I don't understand, and that's my fault. That's my fault. So
no, that's okay. I think there are too many things going on. Chris, really appreciate you.
Leave more things out. It'll be easier to understand.
Chris, leave me. It starts out with 2 boxes and 2 arrows, and then I realize there's more. But thanks for the feedback.
Yeah, Microsoft also has our technical writer that could help out too, Chris.
Yeah.
Yeah.
So if I could just, here's my understanding, and I don't know who the decider is that can say this, but please feel to jump in and answer. My understanding is Dash APIs, Sci APIs are the top level that all conformance tests for Dash will be written to use, and what the final products are expected to interact with the controller with. And if there's any other APIs exposed by the device, whether it's P4 runtime or TDI or whatever, or if any of those are used inside of an implementation, whether it's proprietary, like a proprietary implementation can have proprietary SDK and drivers inside, of course, and the Dash users don't care as long as it talks Dash APIs at the top, right?
That's right.
Yep.
And P4 runtime could be an implementation detail, but that's up to the reference model. But that's just like another proprietary internal API on a proprietary implementation.
Yeah, that is the principle of this.
Yeah,
so
Andy sent me this during the week. Andy sent me this during the week, sort of capture what he just said. Dash and Sci SI APIs are the canonical interface. It doesn't matter what happens underneath. But it's good for us to look at the architecture a bit so we understand what's going on.
It's also good for us to understand that P4 is great. I think it's great. It's a fine model, but more than half of all implementations are not P4. So we have to accept that, and that's why we have this side. It's the same for switching. All the switches had different SDKs. In the end, it didn't matter. We raised the SI up a level so that that wouldn't matter anymore. So the same principle here. And so whether you're P4 or whether you're running C code underneath or whether you're running DPDK, doesn't really actually matter. In fact, you could be a fully software version of Dash running on a server. It wouldn't matter.
Right.
Because we're going to access it through the Dash APIs.
Yeah. The good thing about P4 is that we can actually look at the data plane description and agree on or disagree on the behavior of it. That way, if someone could just write it in OCaml or Python and it would still function, but we wouldn't be able to understand it. Right. So P4 makes it easy to understand.
Yeah.
Right. Hey, Chris, can you go back to your previous slide?
Yeah, sure.
So I just want to make sure I understand this. I mean, like Gerald said, I do have a device that actually has the pipeline implemented and with the Dash APIs. And what is that testing flow as per this diagram?
The begin arrow, Chris.
Yeah,
maybe start at the begin.
Well, that's from the P4 point of view.
Oh, okay.
Yeah, but I don't have P4, and I don't.
Yeah.
I mean,
so let's say we don't have any P4. Then you can almost take this diagram and draw a diagonal line through it and ignore the lower part. We have some test cases that are, functional unit and functional tests, and hopefully these are in some kind of an abstract format that don't presume what the northbound or southbound interfaces are. Just describes a test that can be run by some kind of a test script engine that would then, for example, configure ACL tables. Let's test ACL rules. That's the test case. Test case would say, here's all the contents of the tables. Here's the expected, inputs and outputs of this test. Some kind of a script would then generate site-drift commands to configure the device, and it would configure a traffic generator and run the tests with pass-fail results. That's really the flow, just like straight through here. This is just trying to show the relationship of all the moving parts, so that there's a lot going on. And in order for this to work, the vendor has to implement libsci on their dot. That's like minimum. Be compiled into, for testing purposes, it would be compiled and linked with the sci-thrift server skeleton that's auto-generated. That's also a work in progress. Intel is going to be working on completing this for the Dash Sci APIs. They already have it for the standard Sci APIs. But the test flow is test cases here through this interface. And then this is just a simulation alternative of the same thing. It's just another dot.
Gerard,
just a quick feedback, Chris, on this one. I'm sure there is a legend somewhere for the color coding versus these dashed lines, solid lines, and then there's 3 different types of.
I think the dash lines are the future.
No, there's no legend. It's just this way it came out.
So yeah, legend in the sense that if you basically have some documentation. Because there are 3 different. I see there is solid line, then there is a dash lines, and then there is a gray color line. And then there are a bunch of different, colors used. So just wanted to see if there is no relevance there, then maybe we can simplify it. Otherwise, we can document to see that what do they really mean, right? For clarity's sake.
Okay, thanks for the feedback. I could also turn this into a higher level diagram and then blow up the details elsewhere.
Sounds good. Thank you.
Chris, I'll work with you.
Okay, great.
Gerald, you said that we have already, or we are soon going to have a hardware device that is going to support this and can be tested. Did I understand correctly?
We have there are at least 6 hardware devices in the world that can write code for this that we know about. That doesn't mean that we have hardware available to anybody in the community. If you're making one yourself, you know it, and you'll be writing your own implementation. But in general, any SmartNIC, any modern SmartNIC that has been created recently could run this, and Mellanox is would be one of them. Intel would be another. Pensando and others all can run.
No, of course.
So that's what I mean by the hardware. So these are just SmartNICs.
Yeah, no, of course. I had understood that you said we want to have very soon the software emulator because we already have the hardware. That's what I understood, but I got what you meant. We have the hardware, not the infrastructure, the site.
As the vendors implement this, having a software simulator is super useful for them to know when they're done, because actually the software simulator, I hope, will be the thing that is the golden standard. And then they can use that in their testing. They start off with something. They have something in their hands. We hope that we will actually generate tests for the community, which will all be open source. Mm-hmm. You can generate your own tests, but we want to generate for the community as many tests as we can, so that people who are companies that do develop this hardware, they're starting off with a good set of test cases and a good set of simulators that they can start with, and know that if they go down this journey, that they're not starting from scratch. They can actually reuse a lot of the work that the communities.
Right. And Gerald, if I could add to that, if everyone's agreeing on the test cases and they're consistent, and another supplier comes in and generates a random test case that means nothing to us because they're, generating their own and delivering results that really aren't apples to apples comparison with what we're already doing. So they have to, they would have to conform to what we're asking so we can, analyze.
And by the way, anybody who does generate a test case that is good, though, will take, and hopefully they'll make open source. We're all talking about everything being open source here, guys.
Mm-hmm. Yeah.
Agreeing on all these, there is still one point that for me, I don't understand the logic of it. And the point that I don't understand the logic is why there is the need to define a different language for this P4 extension, while we already have one defined in the PNA. The simulator, fine. The simulator, we can have 2 simulators, 3 simulators, I don't care. But why do we need to have 2 languages? That to me is mind-boggling. I don't think that the simulator depends from the language.
The answer is NVIDIA has offered it and beat us to offering it among all of this group.
Okay, but I mean, but I understand, but here we are in a very initial phase. I think NVIDIA can simulate without any issue in their environment, with their tool, with their whole thing, the PNA language. Why do we need to define another one? Because if we need to define another one, I need a manual for that language.
Just a minute, Mario, which language are you talking about? I'm not sure that I'm following.
It was Silvano, but he was.
Have you seen the pull request that Mario's? Have you seen the pull request that Mario's posted?
Mario, no, we can present it.
Let me remind you. Last time, I think we had an agreement that Mario was going to post a pull request to connection tracking with the syntax, let's say, inspired by PNA. Mario did that.
Mm-hmm.
Right.
Can we take a look at that?
Just Chris? A minute, but okay, go ahead. Sorry.
No, go ahead.
Is
Maddie.
it related only to the pull request, or is it related in general to what to the current P4 model trying to simulate Dash?
Because is related to the description of connection tracking being more aligned with the PNA.
So let me try to answer. First, connection tracking within the PNA is not really standard. It's not an approved standard. It is under process. It's under discussion. And we are NVIDIA have a different, we think otherwise. We believe that the connection tracking should be more generalized and not be like, instead of saying, let's add the connection tracking table, we would like to add a stateful table that can implement connection tracking. We would like to add the infrastructure for that, the language to create that, not the implementation of a specific logic. So you present it as if that there is a kind of an approved standard, and but this is actually not the case. So and to say like, and by the way, the SAI stateful proposal is an open proposal as well. So I can ask the opposite as well. Why there is a way and a need to standardize the PNA when there is a standard SAI API that can solve that?
Matt, I'm sorry, but first of all, the add-on MIS is part of the standard, is the version 0.5 of the PNA spec, which is published on the p4.org site. But also, you know, Dash, as we said several times, is standardizing the API to control the device, not the language with which we express the behavior. So that behavior, the language that we chose to express the behavior is P4, which is not part of the, I mean, my understanding is that the Dash effort is not going to define a Dash version of P4. It's going to define a Dash version of the API of SAI.
That is correct.
That is correct.
But the reference model needs to be implemented somehow. And if somebody goes off and implements it in C++ with no P4 code in it, and everybody agrees that's a good reference model, Microsoft doesn't care. As long as it's
I agree with you, Andy, but I think that since Mario's done the work, it would be at least kind to him to compare the two proposals and see what the group think about the two proposals.
Just a minute.
Sorry,
let
Matt,
me say something.
I'm sorry.
Go ahead, Mario. Sorry.
I'm sorry. Just one additional thing. I think what Silvano was suggesting before is you have a simulator already, which is not supporting the stateful graphs, as well as it's not supporting PNA.
Right.
In a way, you could extend it to support PNA. This way, your simulator would be PNA compliant, and maybe that extension is even simpler than adding the connection graphs. In reality, I guess they are quite equivalent, but I think that's what Silvano was saying before.
So let me try to address that. Actually, what we have is, okay, so we do have currently a simulator that can simulate Dash P4 without, and it actually it's 99% BMV2 V1 model with minor changes, which we are going to share with the community. On top of that, we do have a modified version of BMV2 that can simulate stateful operation as proposed into the SAI community, a generic way to do stateful operation. And we have it working already. Now it is not fully functional in terms of publishing it, and it is not fully functional in terms of it will take a few weeks to make it fully functional. Now, to your question, this is what we have. Again, if Mario is going to write a code that can simulate the P4 Dash API, we will use it. That's amazing, really. It's all around code. It's not around things that we can do. It's around what we can do as a community to be able to simulate Dash.
So, Maddie, it sounds like there's a PR that can be reviewed by NVIDIA then?
Are you referring to the? We are familiar with the PNA.
No, the one from Mario. He submitted a PR for request for comments.
Christina, could you please add Andy as well?
It's public.
Oh, it's in the repo.
It's public.
Yeah, it's in the repo.
Oh,
Yeah.
sorry, as a reviewer, sure.
Yeah, so maybe NVIDIA and the rest of us could take a look at it and make comments.
Yeah, we can also have maybe a call focused on that and discuss a little bit more these advantages and disadvantages of going one way or the other one. I mean, to be honest, from one point of view, as we are saying, P4 is just a way of describing a behavior. That's not what we care and what we are interested in. But if on the way we invent a new type of P4, a new dialect of P4 that the P4 community is not really using, and it's not Dash's goal to extend P4, then why do we do it? I mean,
Yeah, I completely agree. I think in last meeting also we said that we try to remain compliant with PNA. So if we have a way to basically do this thing, and by the way, if we take a different path right now, remember we are only addressing just one use case as we discussed, right? Like VNet to VNet communication. There are far many use cases are remaining to be done in Dash. It's just a very, very small subset that we have just started on. So as we try to basically come up with other reference models for other things, for example, tunneling or, encryption or load balancing and so forth. Yeah, exactly. And then, we don't want to deviate if we can basically, remain. Otherwise, we're just going to go on our own journey and then we will not have a real, concrete way of actually saying, okay, this is how we remain compliant with whatever the P4 or PNA is doing. And that's just, my view on that.
Right, and
again,
we need to. Oh, go ahead.
I must say something. I totally agree, but I totally agree that if there is a standard that can work, it's better to use a standard. If there is a well-known method to do something,
great.
And if there is no reason why not to do it, let's do it. But guys, this is not the case. We are mixing here, things here, I believe.
That's what I was going to say, Maddie, as we have a short-term goal and a long-term goal. And the short term is to have something, get it working now, today, because we have hardware. And the long term is to be whatever compliant, whatever we decide on in the long term. Would you agree, Gerald?
Yes.
Yeah. So because there's a lot of engineers and architects on the phone, the fun thing is to get the short term working and see what we can do. But we do need to align to the future too. So
I actually don't hear anybody on the other side saying that they're going to go off and implement this and give us something in a couple of weeks, right? Unless there's somebody who's willing to give us something in a couple of weeks, a month, then we need to take baby steps and go with what we have. We can't like do a 6-month study waiting for some other thing to standardize and have somebody else who we don't know write all this stuff, right? You either are volunteering to write the code and get it in to the community quickly, or we're just talking about, long-term hypothetical stuff.
Gerald, can I suggest one thing? If that is the case, why don't we let NVIDIA and Intel present their roadmap? Because I haven't understood in reality when NVIDIA is going to have a full solution. I understand that it has something today that is sort of working, as does Intel. But I would like to have on a piece of paper, on a presentation, black and white, something that says we are going this way because it really saves us 6 months, and for that 6 months we are going to pay with proprietary. Let also me remind you that what Mario has used is completely standard.
Let's ask Maddie. Maddie, do you think that at some point your implementation on BMV2 would be migrated to be PSA compliant, so that the investment pays off longer?
The answer is definitely yes. We as NVIDIA, which support P4 in our DPU, are going to have the PSA, to be compliant to the PSA model. And of course, we would like to have a simulator compliant to the PSA, PNA as well, sorry.
So thank you. Let me propose a way of looking at this, everybody, where we all win. NVIDIA has something that's working or almost working that will ostensibly perform functional tests using the SCI interface. That's what our goal is.
Right.
Now, we can argue a lot about the exact dialect of the P4, and right now it's sort of, it's a discussion of P&A versus this modified V1. Sometime down the road, that'll become moot because NVIDIA will then be able to upgrade and align with P&A, and we'll have two ways of simulating the same thing, just different implementations with the same P4 model, same language, the same code. So maybe we just take the gift that they're offering us in the near term as a way of doing functional simulation, and we kind of suspend the pedantic discussion of exactly how the P4 is rendered, because eventually it'll resolve itself, and we can then work on the longer term P&A version. Meanwhile, we have something that's working. That seemed like a reasonable approach. I mean, we'll have these pedantic, I'll call them, discussions about the P4, but that can be kind of a parallel track that doesn't interrupt progress.
Sure. I mean, I think it's a good approach. The only little disadvantage that I see about it is that we will end up with two descriptions, two behavioral descriptions, and we have to make sure that they are coherent, right? I mean, someone has here on the screen the comment that Andy was writing, and one of the things that he wrote is, fine, but I'm not sure that this does exactly what the other code is doing. And I said the same. I mean, it's not easy to understand this code and to maintain it. So this way we will have two sets of code, or at least for certain parts of code, we will have two versions that we will have to maintain coherent.
But the whole point of this is to create a reference test and a reference model. At the second one, if it's second, we'll have to conform to the first one, right?
Yeah, yes.
And produce the same results as the first one does on the reference tests, just as any product would.
Yeah,
I think if they're really down the road, they become equal. We deprecate one.
Yeah,
but we're not. I don't think anybody here cares about deprecation of one or the other later if we decide to go one way or the other. But right now, we need something before we talk about deprecation.
Well, I think there's an understanding that eventually the B and B2 version will run the exact same code as the P&A model eventually will, right? So there'll be the same language, it's a different implementation. That's what I got from Maddie, that they would eventually align.
It will eventually align again. So Mario, if I get correctly, what really disturbs you is it's not around the current. Let's like there is the stateful part, like the connection tracking part of the dash, and there is the rest. Like what you are more concerned about is connection tracking of the dash. Am I correct?
Yeah. Yes. I'm not concerned.
Let me say something. So we in NVIDIA, just a minute. Me as I'm the lead architect for programmability in NVIDIA. Okay, so this is my choice. My choice as NVIDIA is to use a different P4 actually convention. It's not related to Dash. It's related to the way we design our P4 in order to express connection tracking. And this is the discussion I would love to do with you offline. And if we can converge to a single model together with the Intel, if they're willing to be on the room, it is amazing. But it's not related to this project and the simulator. It's a general statement how stateful operation should be expressed in P4.
But that is the same for us. We have a pipeline. We do all this in the pipeline, but we decided that the model must not depend from the pipeline of any vendor. Must be an abstract representation. We have all this running with proprietary extension and whatever, but we are not going to expose that proprietary extension into the model.
Sure, but he's planning to make it open source. He's planning to make an open source reference model of it soon, so it won't be proprietary anymore.
Right. So if you are willing to open source the code that for your proprietary model, fine. I guess it's again, we are looking for in that discussion, we are looking for a DAS simulator. This is really what we are looking for, And preferable simulator will be in a language that we all familiar with. Like if we can really look at on the pipeline that we created and say, okay, I can easily understand that. So currently 90% of it is like that, and there is 10% which is debatable, whether stateful operation need to be done in one way or another.
I'm sorry,
I believe that, so go ahead.
You're right that discussion is very interesting, but and it would be great at some point to do it in some other context and so on. But I think here the point is different. You said it as you were saying. Here we want to have a tool that enables us to simulate and to express in a way that everyone understands what we are trying to do. Our point was simply that everyone understands what is standard. Something that is not standard, it's going to be something that not everyone will understand. That was the whole point, right? I personally like very much your graph. It's a neat idea, but just the point is just it's not what everyone understands. that was it.
Mario, that's fine. Again, that's a very interesting discussion, and we are all in. Actually, this is something we are trying to standardize. It's not actually. You can look at the side. There is a pull request with this proposal for SAI in order to standardize that. So, we can take it in a different forum, trying to figure out what is better. What is the better way to represent stateful, and eventually, I hope that we can come up with the one language, whether it is the current PNA like state connection tracking or something else or something in between, or our graph representation or something in between. I'm not sure what will be the end result. But I believe that to begin with, I think that we should start with what we have, because it is actually mostly functioning, and we can have the discussion about the connection tracking, whether we want to extend that in our graph representation or the PNA like connection tracking. It's a valid it's a valid discussion.
Maddie, if you anyway, I think you are going to publish the descriptions of the new extensions that you've added, right? It would be really good to use them and fill any gaps if there are in PNA as well. That way, everything is from P4Ys. What is needed from Dash is all standard and it's available in PNA as well.
Yeah,
I think as long as it's all open, everybody learns, whether it's PNA or not, right? It's open, and so everybody will learn from it. And which way you go down the road, you still started from something that was open, and somebody did some work, and we all benefit from that. So the faster we make it open, the better. And then we can have some really good conversations.
Okay, so for next time,
I have a suggestion. I think maybe we should look at the Mario's PI and try to understand whether it's equivalent to the existing model. So because I think what we care is mostly whether the API generated are the same or not. I briefly look at the Mario PI. It seems like it's going to define the same table as the previous. Just how to implement the table is different, right? So if they are functional equivalent and they are generating the same API, I suspect that we do not really care about how to implement that connection tracking in the P4, right? So whether it's using the PM model that provided, proposed by Mario, or is Maddie's, more graph model, right? So as long as they are generating the same behavior, I guess we don't really care, right? So then.
I think other people care. I think you're right, Gohan. Microsoft doesn't care. I don't think anybody who's using it cares. But I think other people at this table here do care because they want to be able to basically understand everything that's going on using standard approaches, so that it's easier for anybody to get in here and contribute. I think that was the discussions, and there's. So I think.
I think No, but we should look at the PR. What my suggestion is we should look at PR. It's defined as a option, right? So maybe when we use when we later move to the P&A, we can use that model, right? So and those two models can coexist. That is what I'm saying, right? So
yeah. Let me just
that was I was asking before. At least let's review what Mario's done.
Yeah.
So
it's right here, guys, and I put it in the chat window, and please comment.
We are quite again. We are familiar with the work Mario. We are familiar with Mario work on the P&A. We read that.
Okay, great.
Let me. I be very blunt here. Just a minute, guys. If we are going to work in a community effort, meaning, and when I'm referring to community effort, I'm referring to coding. Then it's totally on the table. So if there are engineers that are willing to code Mario proposal into the current BMV2 V1 model and extend it together with us, amazing, really amazing. I'm not insisting on anything. I want a functional model. If it is not the case, and we are currently doing all the code, so I would prefer to go with my P4 view, unless we will have a side discussion with Mario and he will convince me that his approach is better in terms of programming language to generic DPUs, which can happen. I'm really open to hear different opinions, different approaches.
Okay, so our to-do list for January, we'll have Marian attend, Maddie, yeah?
Yes.
And everyone will take a look at Mario's PR.
Right.
We have 2 weeks off until we meet again in the first week of January. Gerald, anything else you can think of on the to-do list?
Can I ask also if we can have both NVIDIA and Intel tell us what is the timeline for their simulator, for their software implementation?
Not a problem, Mario. Let's next time in the next meeting, Marian can show a demo of what is working, and then a timeline on what is our plan, assuming we are working on our own to complete it.
That's great.
Okay.
Yeah.
Yes. And Mario, as I think Andy mentioned earlier, that P4DPDK part can be like this second dash reference model, based on standards. That will take some time and would really, request help from the community to enhance it. Once we have some basic feature set implemented, we definitely plan to open source it.
Yeah, but what I was asking, and you don't have to answer now, is if you can give us an idea of the timeline. Like, is it going to be available in 6 months or in 4 months? But if you can, otherwise, obviously not. I mean, it's just
right. It might be 4 to 6 months as of right now, from what I'm seeing.
Thank you.
Okay, yeah, maybe we can talk about that. Does anyone else have to go? I kind of have to go.
But I think that Maddie was suggesting meeting with Intel.
I can set up a meeting.
Connection track, and we should not wait till January. We shouldn't wait for anything to have these discussions.
Well, the holidays are like basically today through the
But don't assume everybody's on holiday.
okay.
Not everybody's going to be on holiday.
Would you guys like me to set up a call between Intel, NVIDIA, Pensando, or you want to do that on your own?
For sure, Christina, that would be
great.
Okay, all right.
Looks like
I am
January
volunteering for the community to work on my vacation and do this. So,
okay. And Christina, one quick note before we log off is that we shouldn't entertain at least in my view, two data model or two behavior model to coexist, right? Mm-hmm. Because we generate SAI APIs with them. So community should basically strive to converge on a single model. Okay. And then that should be our goal, right?
Okay, and that's Mario talking. Okay.
This is Hanif.
So where is that being written?
Hanif talking.
This is Hanif.
Go ahead, Gerald. I'm sorry.
I didn't see you write down what he said.
I have a second screen going.
Okay.
It's not being presented, so yeah. So I will write that down. Okay, guys. Well,
yeah, Christina,
super great. Go ahead.
It wasn't Mario. It was Mohammed.
Okay. All right. My teams must have been lagging a little bit. Thank you. So I guess we'll see each other in January, and I'll set up some little meetings in between. And Marian will come in the first meeting in January. We'll have another discussion. And then Chris will update his testing document. And yeah, sound good, guys? Anything else?
Thank you so
on
much.
the to-do list? No. Okay. Email me if you think of anything.
Good progress, everybody.
Okay.
Yeah, thank you, and happy holidays, guys.
Yeah, you too.
Happy holidays.
Thank you. Bye-bye.
Bye-bye.
Bye.
Bye-bye.
Holidays.